Hello, my name is Chan Siriko Justit. Today I'm going to present our group project, Simulation and Analysis of Harmonic Filter for Mitigating Harmonic Distortion. First of all, our subject is power quality. Code subject BNE 32603. Lecturer name is Dr. Farida Hanim binti Muhammad Noor. Our group member is Davidson, Chan Siriko, Tang Lok Yuan, Muhammad Hazik Farhan, and Lionel Avon Laing. First of all, we move on to our content. We have eight content: abstract, introduction, brief of PQ problem and effect to the industrial sector, brief about proposed mitigation device, circuit design and simulation, result for the PQ problem, and circuit design and simulations result for PQ solution. Next is discussion. Lastly is our conclusion. First of all, abstract. The objective of this project is to develop a shunt active harmonic filter that could reduce or eliminate harmonic that could damage electrical machinery and equipment from overheating, unintentionally tripping, and measuring things incorrectly. The distribution of harmonics is often viewed as an undesirable, expensive, and occasionally harmful byproduct of electrical systems. The THD is a metric used to assess voltage distortion caused by harmonic current ejection by utility systems. To discuss the difference between having the filter in stock or not, MATLAB is used to analyze the filter that is included. Electronic equipment cannot accept THD beyond 5% without experiencing malfunctioning. Hence, the design and implementation of the filters are specially illustrated with respect with the IEEE 519/1992 maximum limits of 5% THD. Introduction. Series or parallel resonance circuits called harmonic filters are used to shunt or block harmonic currents. By lowering the harmonic currents entering the power system at the source, they also lower the harmonic voltage distortion. These pricey gadgets should be only used after considering alternative approaches to harmonic limitation. It is not always easy to use these filters in a certain context. To produce it first unexpected resonance, the filters themselves may interact with the system or with the other filters.
Hi everyone, my name is Tamu and I'm one of the members from Group 4. For today I will present about the part of brief about PQ problem and the effect to the industrial sector. So for the power quality problem has differentiated into two variations. One is steady state and another one is event variation. In the steady state variation, there are included voltage unbalance, harmonic interharmonic, voltage flicker, voltage notching, and noise. In the event variation, there are included function, voltage set, voltage cell interaction, and the last one is DC observe. The effect of PQ problem on industrial sector are included loss of production, manufacturing interruption, loss of revenue, productivity costs, decreased competitiveness, lost opportunities, data damage, waste energy, and lastly, decreased equipment lifetime. That's it for me. Thank you.
Hello, my name is Leon Avun. I will present the part brief about proposed mitigation device. Harmonic filters are resonant circuits in series or parallel that are intended to shunt or block harmonic currents. They lessen the harmonic currents that enter the power system from the source, which also lessen the harmonic voltage distortion. It is not always easy to apply filters in particular circumstances. The filters themselves may interact with the system or with other filters to create resonance that were previously unanticipated. The nature, the distribution, or rating of the filter group should therefore be determined using harmonic studies in all but simplest circumstances. In particular, low-impedance harmonic filters are made to ensure that harmonic currents travel between the loads and filters rather than power source and other parts of electrical power generation and distribution system. Filters can be divided into three categories, which is passive, active, and hybrid. For passive filters, capacitor, inductors, and resistors are examples of reactive path used for passive filters. They have been tuned to offer a low impedance path for particular currents with unwanted harmonic frequencies. Passive systems with several possible drawbacks can result in resonant circuits running parallel to the power source, worsening power quality condition. And active power conditioning electronics are used by active filters to make up for undesirable harmonic currents to specifically reduce harmonics. Active filters adjust for the deformed sinusoidal current wave. The ability of active filters to adapt to dynamic changes in electrical distribution system is one of its advantages. Hence, because they have a stronger ability to react to significant disturbance, active filters can be taken into consideration for more intricate and crucial systems. However, the cost is slightly higher for compared to passive filters. And lastly, combination of active and passive filters are known as hybrid filters. They profit from the advantages of both filters. They utilize in particular application the system in which they can be installed are single-phase, three-phase, three-wire, and three-phase four-wire distorted system. The active elements can, by carefully controlling their operation, reduce higher harmonics, whereas the passive circuit only perform basic filtering action at the dominant harmonic frequencies. Active filtering size and expand will sub- substantially reduce as a result. That's all from me. Thank you.
This is the circuit design and the simulation result for the PQ problem. On the left side is the result for the PQ problem. As you can see here, the edge of the waveform is a bit edgy and are not smooth. This could be bad for the electric railway. And on the right side of the slide, this is the design of the railway medium voltage line. There is no harmonic filter applied yet. On the next slide, this is the circuit design and the simulation result for the PQ solution. On the left side of this slide, you can see that is the data of the result for the PQ solution. There's changes on the waveform where the edge of the waveform are smooth and are not edgy. This is the design. As you can see here, there is a three-phase shunt active harmonic filter connected to the bus.
Next, we move to our discussion. Active power harmonic filter is a relatively new technology for eliminating the harmonic, which is based on the power electronic devices. An active power filter consists of one or more power electronic converters which utilize power semiconductor devices controlled by integrated circuits. The use of active power filters to eliminate the harmonics before they enter a supply system is the optimal method of dealing with the harmonic problem. Shunt active filter is controlled to inject a compensating current into the utility system so that it cancels with the harmonic currents produced by nonlinear load. So based on our result, we got our power factor which equals to of the peak is 0.9489, which is very good, because it is uh, it is above 0.85. And then our THD, mostly of it is less than 5%. So it is safe to say that our project may be completed by developing the process of this filter used in three-phase power system. Although elimination of this filter was conducted in order to have a comprehensive understanding of many prospects of these active filters. The widespread usage of power electronic control devices mostly result in harmonic injection that exceeds allowable limits. Utilities are having difficulty maintaining required power quality at the consumer end, and consumers are being forced to pay the consequences indirectly through higher plant downtime, or ATC. In the long run, these utilities will persuade users with nonlinear load to employ the power factor to keep the power quality in an acceptable levels. The IEE 519 is used for harmonic limitations in this case. MATLAB simulation was used to examine and appraise the various strategies. Thank you very much.
Next is we do a simulation test for this design. This is the design for the medium voltage line of electric railway without a shunt harmonic filter. They can see the edge of the waveform are a bit edgy and not stable. This can affect the electric railway performance. We should get rid of these PQ problems by applying a harmonic filter. Let's move on to the solution of the PQ problem. So this is the design for the electric railway medium voltage line with a three-phase shunt active harmonic filter. As you can see here, the waveform of this harmonic filter made the edge of the waveform are smooth. They are not unstable like the one without the harmonic filter.